The trick with superhydrophobic technology is not just in creating a superhydrophobic surface, it's making a durable one. Our durable surfaces are far beyond what anybody has out there. So we have the key to make an interesting technology useful. We've made great leaps in durability, which is the key to successful superhydrophobic surfaces.
And I think that is what ROS Technology has done, is taken these coatings to the next level of the most superhydrophobic coating that we know in both United States and overseas.
Now we're getting thousands and thousands of rubs before failure. Our surfaces are very durable, and in being very durable, they're very useful. Corrosion is created by water. So if you can keep water off of any ferrous surface, it will not corrode. Because superhydrophobic surfaces keep an air barrier between any water and the surface itself, corrosion doesn't occur.
And the superhydrophobic coatings have a real strong potential of keeping the moisture away, because water never comes in contact with the surface long enough to form any kind of oxide, which is the net product of corrosion.
When you coat a tube with a superhydrophobic surface, any liquid that travels through it much faster. And it makes sense, because instead of the edge of the fluid rubbing against the tube, it's rubbing against air, which is what superhydrophobic surfaces create at their boundaries. So water shoots through superhydrophobic surfaces quickly.
And in the end, if you're using pumps to transfer that flow, you save energy.
Now, water does not stick to our superhydrophobic surface, but as it bounces down on it, it grabs any dust that might be there, which would rather stick to the water, and then it rolls off with the water. So it creates kind of a snowball effect in rolling up all of the dust and dirt and rolling off. So you'll have a surface that every time it rains, cleans.
When you have high-rise buildings where it's very difficult to get up to the surfaces, up to the heights, if we could apply our coatings and literally either they will be self-cleaning with the rainwater, or a very simple squirting of water would keep them clean.
Ice does not stick to superhydrophobic surfaces because the water droplets can never adhere to the surface. They just roll right off. So at the end of an ice storm, if you've got a superhydrophobic surface, it's dry, just like it was before. Whereas if it's anything less than superhydrophobic, the ice is attached very stubbornly to it.
Take the same coatings with some changes in the chemical constituent and make them also repel oil. We can also extend our process to make cardboard non-wetting.
Think of boots that when you step in the mud, you pull them out and they're completely clean. And these are all applications that are great for superhydrophobic technology.
Based on these new findings, we can now develop products that will touch the consumer market, industrial market, and every possible energy sector. R&D 100 is a recognition that the R&D magazine issues once a year, and these are the top 100 technologies, not only in the United States but across the world. And if I may brag about it, this is our 12th R&D 100, which is the most R&D 100 anybody's won in the United States at this time.